You can stop the tape. Stop. Everyone is fine. Now, let us learn the basics of kinetics. The rate equation. What is the equation? We know the equation is balancing, but this is the rate equation. This is not about the balancing of the rate, but equation represent the equal to sign. We are considering about the rate. We are more concerned about the rate. So what is rate? Rate is the disappearance or appearance of the disappearance is with respect to reactant or appearance is with respect to product. So disappearance or appearance with respect to time is I'm clear now. Okay, then rate we know is disappearance. So disappearance means a reactant. The here reactant is A, capital A. Small a, small b, small r, small s are the moles, number of moles. And capital A, capital B, capital R, capital S are the components or are the components, and capital A and capital B are on the reactant side, and capital R and S are on the product side. So capital A and capital B react to form capital R and capital S. So disappearance means A and B are disappearing with respect to time, and R and S are appearing with respect to time. So what is the rate of reaction? Why it is disappearance of what? This concentration is disappearing. So dCA upon dCA divided with dCT. And as we well know, concentration is number of moles per unit volume. So the equation derived is D represents the derivative and derivative of concentration with respect to time. So we are calculating the rate of reaction A. So negative sign is the negative sign shows disappearance. Okay. The unit is as per the first order reaction. The unit zero order reaction. The unit is mole per meter cube per second. And the rate of the reaction is a function of temperature and concentration. Concentration, as we are aware of, we already calculated kCa. The power of the concentration represents the order, which we will discuss within a few seconds. The K is rate constant. Its units matter a lot. We have to calculate the units with respect to the rate. Rate constant unit. For zero order reaction, for first order reaction, second order reaction, the units of rate constant are different. So rate of the reaction is a function of temperature also, as per the Arrhenius equation. Negative of R is equals to K naught EA e to the power minus EA. EA is your activation energy, as it is written here, R upon T. Okay, so we conclude from it that rate of the reaction is a function of temperature. Then single and multiple reaction. What is single reaction? Single reaction is when the one component is forming one product only. As we are able to see in this reaction that one component is reacting and one product is only forming. So this is a single reaction. These all are multiple reactions. Why multiple reaction? Multiple reaction is further classified as parallel reaction, single reaction, competitive reaction. Series reaction is what? When where in series a product is formed. Firstly, A is forming R and R is further forming S. This is series reaction. Parallel reaction, A is forming R also and forming S also. And we have the kinetics for both series reaction and for parallel reaction. We will discuss that. Then elementary and non-elementary reaction. Elementary reaction which occurs in single step, and non-elementary reactions which occur in more than one step. And we can say that where the stoichiometric equation are aware and we are aware about the stoichiometric equation. As per we are able to see in this equation, as we are able to see in this equation that uh, rate of the reaction is, we are able to calculate the rate of the reaction with respect to stoichiometric coefficient, but in non-elementary reaction we are not able to get the rate of the reaction with respect to stoichiometric coefficient. Then molecularity order. Molecularity is the number of molecules reacting, and order is according to the rate law. We are calculating the order. We what is the rate law? Let us take this example. It is already written here that rate is k molecules are reacting 3 and order is 2, because for the pure state, that is oxygen is pure state gas, hydrogen H2, chlorine, these all are in the pure state. So their power is 0 and anything raised to power 0 is 1. So order here is 2. It means 2 moles of NO is reacted, that is the rate. Rate is this, but order is 2. Now units of rate constant. We are given the general rate law. But what is the units with respect to, what is the units of rate constant, not rate. Rate unit we already know. How to calculate the rate unit? Just a minute. Rate unit is N A upon B. This is concentration. dC upon dt. This is mole per meter cube. And time is in denominator. So this is second. So this is the unit of rate, that is negative of RE as per any reaction. But for the, this is for the zero direction, and its raised to power 0 is 1. If we put n is equals to 0, we get the value of k is equals to this mole per meter cube per second. Instead of meter cube, we can write liter also. That is why for the zero order reaction, the units is mole per liter per second. For the first order reaction, a to the power 1. Okay. Then in the Ca, this is concentration. If you put the value of concentration here, then let me do in the next slide. For the first order reaction, if we see the rate of the reaction unit is mole per meter cube per second. I am taking meter cube, but we can take liter also. Then here Ca to power 1 K, and K unit we have to calculate. In next step, mole per meter cube per second is equals to, we can put the concentration unit, that is mole per meter cube K. This is cancelled. So K unit is per second, and we are able to see from this also that K unit is per second. Similarly, we can calculate the units for second order, third order reaction. Thanks, that is all.